Hey guys, it's Dave Millard from Eco Wise Homes here. Just here at my project at Sedgwick. I thought it was time to check in and give you guys a bit of a look what's happening back here. So let's flip this camera around and go get into it. So yeah, as you can see, it's been a while since I tuned in. Last video I did with you guys was slab stage, but the slab's cured. Give it about 3 weeks to cure here. We've got a burnish finished in here, but get down here, I'll show you how it's all progressing. Right, so down this end here, we have no trusses. We've actually got, a steel portal frame for bracing down the far end. Then in between here, we have timber portals, TAS beams that are done by the truss joint. And then all rake seal in this living area, and then the rest of it's truss. So I wanted to build the wall frames and trusses down there. That way we can work out. We're using 140 wide stud walls. 140, normally they're only 90mm, so we can R4 insulation bat in there. Studs are normally spaced out at 450mm centres. I space them out at 600mm. So yeah, guys, as a chip in that, I was always an apprentice, I was always taught just to put more timber in it, make it like structurally sound. And yeah, don't get me wrong, we've still got to take structural integrity into consideration, but now I'm a lot smarter about where I use my timber. Obviously, definitely take structural integrity in consideration, but the less timber you have in a home, the more insulation you can have. We don't do normal 3-stud corners, we do what's called California corners. So normally there's a stud. Normally there's a stud that gets installed there, and the building gets wrapped on the outside of the studs first, and then guys come along afterwards and install insulation in here and in there. Because that's been wrapped from the outside, they don't get insulation in that corner. So yeah, definitely a big no-no, high performance construction. So we use what's called a California corner. So just a 2-stud corner, it's one less thermal bridge, and we will just put a piece of plywood or timber on the back of that stud to pick up plasterboard. That's the sole purpose of it. Get insulation but tucked right around the back there. Again, build smarter. And then here, guys, we have a internal wall running back through here. So normally you would see stud there, and then another stud gets built there for to pick up the plasterboard on this wall. And again, because that stud's there, they wrap the outside, insulate here, insulate there. That gets missed because that stud's sitting there. And then again, cold spot in your home. So what we do is we put noggins crossways just to suit plaster, and that's it. But we don't have any internal walls. We do all the external plaster, do the ceiling first, then we build internal walls afterwards to get the air tightness. But yeah, you can see here, guys, we've got our plywood. So that's the connection from our plate. Sorry, let that zoom. So that our plasterboard will get glued to that plywood, and that connects to the outside. You can see here we've got the wet area down there, that's the ensuite, and another wet area here. Yeah, literally are wet areas at the moment. So yeah, we're working on our portals now. So here we've got the Tassie beam, so Tassie oak timber portals from the truss joint. So these are going to be exposed to this end that we haven't built yet. And as you can see, nice powder coated black brackets. A bracket up in the apex there. So the truss joint didn't know the full length of it, obviously, until we get our upstand. So I'm here cutting all these vertical columns to length, and again that black bracket will go on the end of that, so the bracket there. And Das is just housing out the plate, so the base plate will slot in there, and then Dan's doing some bolting over here. So yeah, Dan's housing those out. Here's one he's finished over here. As you can see, it's been checked out there. The dust is done. So then that concrete slab finishes perfectly flush with our timber. So yeah, we're all set, ready to lift. Got all the portals set up over there, timber ones. You got the steel over there, and the boys are lifting. So as you can see, yeah, the frame's pretty much done here. We're going to do some wrapping of the roof with the ventilated cavity, which I'll chat you in a second about. So yeah, this is the north due this way. There's going to be a 2 sliding doors here with some highlight windows above it, and louvers and that, and timber pergola area out here where the foundations are, and that timber pergola area will continue down that side. But yeah, man, these Tassie beam timber paws I got from the truss joint are pretty impressive. Obviously a shame that we have to wrap them up, but in the weather and that's the best thing. But I'll see if I can pop open a section and give you a bit of a look. Yeah, you can see in here like powder coated black plates. So it's at the plate at the bottom. Oop, nearly fell off. Plate at the bottom, plate in the junctions, then up at the apex as well. But yeah, man, time they're stained up, they're going to be pretty damn nice. The concrete slab here is a finished concrete slab. It's going to be a burnished finish. But one thing, like as a builder and that, like you got to make sure you organise and think of things. I've actually got so at framing stage, we've already had the polished concrete company come in and burnish around these 6 portals in here. Yeah, I was concerned that, you know, they couldn't get their machines in here and yeah, probably in there and get that neat finish it required. So I don't actually, you can sort of see that darker sections where they're burnished up already. So yeah, thinking ahead and making sure you're onto it, and trying to get that best finish possible for the client. One of the tasks I have for every project is to just confirm the window schedule and that. So it turned out that there's a doorway going through here and another another window going through there. Now, I wanted to make sure for this project, and hard to see there, but that gap there, so that's the timber portal there, and that gap there to the timber portal, and then that gap there to the plastered wall is the same. And I want to make sure the same here, that to that timber portal there, to that window there, and the same again with the portal there. So the portal there to the window is all the exact same. So for whatever reason, the plans had a slight discrepancy to what we actually have on site at the time. The dimensions of the timber portal were a bit different to the structural engineering and that. So you know, I just slightly tweaked the window size just to make sure we get the same amount of plaster either side. So yeah, air tightness. Got airtight plate, polyurethane down the concrete slab, every connection joint in it, fully polyurethane. So building wrap will go down the wall, connect that to the airtight plate. I'm actually looking at doing something maybe a little bit different compared to the last project, but yeah, stay with me and see what we do there. So yeah, all the way up, you can see here where we started a strip of wrap. Again, that's been taped up the top, and that's been taped to this piece of 17mm plywood, which then our plaster will get glued up there and polyurethane along there, and obviously, you know, it's a 16 or 17mm batten on clips to be flush with that, and plasterboard right through. Another thing is all our plasterboard that gets installed on the walls will get sealed up to airtight plate across the bottom, sealed around all the window openings, and any of the power points and plumbing pipes will get sealed up with airtight boxes and that to get a good air change. Yeah, you can see the wall wrap that we use on this project. It's a Smart Tech product. It's a roof and wall commercial product. It's really good. I'm really impressed with it, actually. It's got really good vapor permeability, and yeah, it's really good high strength stuff. You can see it's got the, sorry if that zooms, see it's got the paper woven back in. So that's from Stuart from Thermalux. He's a guy that started a business who supplies high performance products as far as tapes, wraps, XPS insulation, and bulk insulation, and also, you know, can supply and install bulk insulation. So if you are someone that's looking to improve the performance of your new home renovation extension, go check out Thermalux. So I touched on it at the start of the video, but anything that side, we're going to wrap the roof, do a ventilated cavity, and I'll explain you the reason in a second. And then anything that side is we're going to do a ventilated roof space. So the actual roof here will be pretty standard to, you know, what I call standard construction in Australia, is that we're actually going to, you got timber battens up there, not steel timber, less condensation. We're going to have an anti-con blanket on top of that, and that roof cavity will be designed that we've got a ventilated wall system on our walls on the outside of the frame, that air can flow up underneath our cladding all the way up into the roof space, and then you know, get good airflow on that roof. The ridge capping has a Lysart venter roof system. You know, we want that roof cavity to be as much as possible to the external air temperature to minimise condensation. And you may ask, why here we're doing a ventilated roof cavity with paper on top? Well, this roof here, it's quite a large like roof space. We can get airflow going all the way, you know, through the trusses and that. But yeah, in this section, we've got the timber portals that are seen in the plastered or inside the house. And then we have these purlings going horizontally here that are 290 deep, and they'll be pretty much filled with insulation to get our thermal performance. So you're not going to, and then a batten on top, and then a batten on top, and you're not going to get much airflow through there. So yeah, guys, all wrapped up. You can see the little strips going down the rake of the roof. They're our counter battens, and then our roof battens run parallel with our purlins behind there. So the actual roof battens, the counter batten sits 20 mil high. So in between the wrap and the top of our roof batten, we have a 20 mil cavity in between the counter batten. So that's what you call the ventilated cavity. And again, yeah, that's just all come about through no ventilation in the roof space, which obviously down this other end we have the ventilated roof space. Yeah, all these building details are a bit different to what you may normally see, but this has all come about from a cost perspective and buildability. You know, high performance construction, I'm a big fan of it, but it can add a fair bit of extra cost to a project. So it's all about trying to build and design that are relatively cost effective compared to other methods and that sort of thing. So hope you're enjoying the content, guys.